So now let's start talking about the individual studies one by one, talking about the most important characteristics of each. And we will start with descriptive studies and start with the simplest type of descriptive study, the case report. It's a succinct written account of a single unusual case. So here the number is 1, in which the treatment or management of the disease or condition is worth reporting. That's the case report. A case series is very similar, but it's just a report of a series of patients. So the number here is more than 1, with similar diseases or conditions that describes their management or treatment, and you present it in a descriptive study. A correlation study, aka ecologic studies. Here, these are used to conduct studies of aggregate or population characteristics, not individuals. So you're not talking about group of patients, you're talking about group of people, aggregate, a country, whole country population. They can only report that a correlation exists and cannot show an association exists as they compare population or aggregate data without knowing individual data. And that's an important kind of negative aspect of these ecologic studies. Correlation studies must be interpreted with caution, but still important information can be obtained from the trends that could identify disparities and lead to further studies and hypotheses testing. Now, the rest of the descriptive studies, we have to think about this timeline. So the cross-sectional studies along the timeline, where are they located? Right now. In cross-sectional studies, also known as prevalence studies, both exposures and outcomes are collected simultaneously, right now. These studies provide a kind of a snapshot at one point in time, and thus exclude people who have died or who chose not to participate, which can introduce some sort of bias. Temporal relationships are difficult to determine in these studies, as only prevalence can be determined, and the risk of developing disease cannot be estimated. These studies can provide timely descriptive data about a group under study, but they do not tell us about causality or the true risk of developing a certain outcome. Like you want to know right now what is the prevalence of HIV positive patients in a certain city in California, for example. So this is the cross-sectional study. A cross-sectional study is a fairly quick method to obtain descriptive data and can be useful in identifying the prevalence rates for specified populations. Cohort studies. This is a very important and reliable type of a study. Cohort studies or cohort designs can be either prospective, which is kind of the most common type of cohort study is prospective. Like by default, a cohort study means a prospective study. But also we have what can be described as retrospective cohort. In a retrospective cohort study, which is a design which is less common, exposure is ascertained from past records and outcome is ascertained at the time the study begins. But the classic standard prospective cohort study, the investigator begins with a defined population. And then, so you have a defined population, I'm starting with it right now, and you divide this population into 2 groups, and you follow a group of individuals who were either exposed or non-exposed to a factor of interest. So you have one group exposed who will be exposed to a factor of interest, risk factor, and another group who will not be exposed to this factor of interest. And then you follow both groups to compare the incidence of an outcome. So you have one group that you know that they have been exposed and they will keep being exposed to a risk factor, and another group that you know that they have not been exposed and they will continue to not have been exposed to a risk factor. And you follow both groups and you look for the incidence of an outcome, the appearance of new cases. If an association exists between the exposure and the outcome, then the incidence rate in the exposed group will be greater than that in the non-exposed group. And the ratio of this is what we call the relative risk, which is a measure of the strength of an association between an exposure and an outcome or a disease. So if we put this in a table and learn how to calculate the relative risk and the absolute risk, sometimes known as the attributable risk in a cohort study. So here we can have two groups. One group there is exposure, and in another group there is no exposure, and here's the disease or no disease. And we just put A, B, C, D, they stand for numbers. So if we want to calculate the incidence in the exposed group, so it's going to be, the incidence is going to be, this is the exposed group. So it's going to be A and B are the exposed group, but the incidence is only A. So it's A divided by A plus B. If we want to calculate the incidence in the non-exposed group, which is incidence non-exposed, so C and D are non-exposed, but the incidence is only in C. So we want to know the ratio of this C to the total of non-exposed. So it's going to be C over C plus D. The relative risk is simply, we divide the incidence in the exposed by the incidence in the non-exposed. Whereas the attributable risk or the absolute risk is the incidence in the exposed minus the incidence in the non-exposed. So the relative risk is the incidence rate in the exposed group divided by the incidence rate in the non-exposed group. If this relative risk is 1, which means the numerator equals the denominator, then the risk to the two groups is equal. Then this does not mean, this means that there is no association between the exposure and the outcome because it did not make any difference. But if the relative risk is more than 1, which means the numerator is greater than the denominator, then the risk in the exposed group is greater than the risk in the non-exposed and can be considered a positive association. So that's a positive association. Now you know that that exposure is related to the outcome. If the relative risk is less than 1, which means the denominator is greater than the numerator, then the risk in the exposed group is less, actually, than the risk in the non-exposed group. And this can be considered protective. So if you get exposed to that whatever factor, this might give you some protection and you will not develop the condition as expected. An example of a protective association may be the association between exercise and heart disease. Exercise can actually reduce the risk of heart disease, and exercise will have a relative risk that is less than 1. Thus, it is considered a protective exposure. What about the attributable risk? It's the same table, how to calculate the attributable risk, sometimes known as absolute risk or risk difference, is the amount of risk that can be attributed to an exposure. For example, it's well known that smoking can cause lung cancer, but lung cancer can also occur in non-smokers, right? So the amount of disease that is associated with risks or exposures other than smoking, this is called the background risk. In order to calculate the risk attributable to a particular exposure, we have to subtract the incidence of disease, which is lung cancer, in the non-exposed group, the smokers, minus the incidence of disease, lung cancer, in the non-exposed group, or the group that was exposed to the background risk, all other risk factors other than smoking. This value is considered the attributable risk due to exposure. So it is, as in this equation, the incidence in the exposed minus, not divided by, minus the incidence in the non-exposed. So long story short, relative risk, we divide the incidence in the exposed by the incidence in the non-exposed. Attributable or absolute risk, we subtract the incidence in the exposed minus the incidence in the non-exposed. In general, cohort studies are best carried out when the investigator has good evidence that links an exposure to an outcome. When the time interval between exposure and the outcome is short, because you do not want to spend years ahead doing this study, and when the outcome occurs relatively often. So it's better to do cohort studies for the more common diseases, not the rare ones. One of the major problems with cohort studies is that they can be very time-consuming and expensive, especially if the cohort needs to be followed for a prolonged length of time. Diseases that are rare or that take many years to develop may be better suited for a case control study, as it can be difficult to follow participants for many years, especially if the outcome of interest is rare. The longer the time period, the more likely participants will be lost to follow up, and multiple exposures can potentially confound the relationship. So these are some of the kind of negative aspects of cohort studies. Okay, I'm going to end this segment here.